As you know, strings are composed of characters. A string in C# internally contains basically an array of char instances. And in turn, a char is really just a 16-bit unsigned integer, which can contain any number from 0 to 65,535. A lot of C# programmers think of a char as representing a single Unicode character, but that's not actually quite correct. Very often, the value of a char does represent a Unicode character. For example, the value 65 represents capital A, while 112 represents small p, and so on. But that's not always the case. Things are sometimes more complicated. I don't want to go into too much depth on Unicode, as that's a bit off topic for this course, but in order to understand how string comparisons work, we do need a little background knowledge of the issues involved in trying to store Unicode characters in 16-bit char instances. So what I'm going to do is just introduce a couple of Unicode concepts and give you a couple of examples which will demonstrate some of the reasons why char instances don't always map to what you'd intuitively think of as a character. First up, a piece of terminology. When I say that the number 65 represents uppercase A, what I actually mean is that 65 is the Unicode code point for uppercase A. We normally write this in hexadecimal, prefixing with U+, so the code point becomes U+ 0041, because the hexadecimal for 65 is 41. Similarly, the Unicode code point for lowercase p is U+ 0070, because 70 is hexadecimal for 112. There are two ranges that are well worth remembering in this regard. The uppercase letters form a continuous sequence of code points, starting with uppercase A is 65, or 41 in hex, and going up to uppercase Z, which is 90. On the other hand, the lowercase letters form a similar range, but using higher code point values. Lowercase a is 97, or 61 in hex, and that leads through the alphabet to lowercase z is 122.